Hi, so in this video we're going to take a look at circles and sectors. Okay, so we have a circle here, as you can see, and the radius, which is the length that always goes from the center to the outside, is 12 centimeters. So if we take a look at our log tables to see what formula we have on circles, if you go to page 8, you will see here's where we have circles or disk, and we have two formula. We have L equals 2 pi r and we have A equals pi r squared. Now A is obviously standing for area, but the L here is worth noting, that is actually standing for the length. Do you see the way the L is here? It means it's the length of the outline of the outside. So the other word we use for that is circumference. Okay, but they use the letter L. So the circumference is 2 pi r, which is the perimeter, if you like, the length of the outline of the circle, and A, which is the area, in other words, how much space that circle takes up, is equal to pi r squared. So what we're going to do is I'm going to show you how to use that formula. A formula, as I said, that is given to you in the exam with the log tables, and we're going to find the area of this circle, how much space is inside, and we're also then going to find the length of the outline of the shape, in other words, the circumference or perimeter of the shape. Okay, so we'll start with area. Okay, so again, if you've watched the video on the basic area of shapes like your squares, rectangles, triangles, parallelograms, it will give you another insight into exactly how we're going to tackle these. A little bit more complicated with the circles and sectors, but it'll give you a great basis of how to tackle these ones as well. And what I've always said is when you identify your shape and you identify what the question's asking, in this case we're going to do area first, write out that formula in full. So we have A equals pi r squared. Okay, and now we start filling in the bits we know. Obviously we don't know what the area is, that's what we're looking for, so you may keep A as A. Now when it comes to pi, okay, so there's a couple of things you're going to have to look out for in the question, all right? They may tell you to take pi as 3.14, all right? Or they may tell you to take pi as 22/7. Or they may ask you to do it in terms of pi. Okay, I'm going to do it all three ways just so you know exactly what to do no matter what way the question asks you to take pi. The first one I'm going to take pi as is 3.14. So literally all I'm going to do is I'm going to sub in, instead of pi, I'm going to sub in 3.14. So as always with your substitution, whatever you sub in, keep brackets around it. So I'm going to put 3.14 for the pi. And now I'm going to sub in for the r. Now the r is standing for the radius, and I've already highlighted that 12 centimeters is the length of the radius, and the radius length is always going from the center, any line from the center to the circumference of the circle. Okay, so just like it is there. So the radius is given to me, the radius is 12. So instead of r squared, I'm going to put in 12, put it in brackets, and don't forget squared, okay? You have to follow that formula exactly. So we have 3.14 times 12 squared. And then what I'm going to do is I'm going to type that in exactly like that on my calculator. Bracket 3.14, bracket, and then I'm going to open the bracket again, 12, close the bracket, squared equals, it comes up as a fraction, but most likely you'll be asked for decimal places, so just watch out for that detail in the question as well. I'm going to give it to the decimal place, so I'm going to do 452.16, and that is my area. Now don't forget, and I highlighted this in the other video as well, don't forget your units. Anything that's to do with area is going to be squared units. Given that it's centimeters, it's going to be centimeters squared. Okay. Super. So again, you have the formula, it's in your log tables, get it written out in full, and then all you need to do is fill it in. Let's try now when you have pi is 22/7. So all you do in this case, after you've written out your formula in full, we're looking for the A, so obviously we can't fill anything in for that, so keep it as A. But this time pi, we're going to sub in 22 over 7. So in brackets, as always, whenever you're subbing anything in, put in the 22 over 7. And then or is of course still 12, and don't forget squared, okay? Make sure you're following that formula exactly. This time round, I'm going to get my calculator and I'm going to do bracket, and this time I'm going to put in the fraction button, okay? So the box over the box, that's that button there, right? Box over box. And on top I'm going to put 22, and then I'm going to scroll down on the bottom, I'm going to put 7. And then I'm going to come to the side and close my bracket and open the bracket again to put in 12, close the bracket, and then squared. Okay, so you're typing into the calculator exactly as you have it filled in here on your paper. And so again, I get a fraction, so I'm going to press the S to D button to get it as a decimal. Now I'm getting a big long decimal here. And you can see it's not quite exactly the 452.16 that I got over here. And that's just because your 3.14 and your 22 over 7 are approximations for pi, okay? Pi is a number that goes on forever. So obviously we have to cut it short to be able to put it in as a number in our formula. So they're approximations. So we are getting something very close. But just not exactly the same. I'm going to do 2 decimal places here. So it's going to be 0.57. Look at the number beyond. 1 doesn't make it bump up, so we'll keep it as 452.57. Okay, so the area is 452.57 centimeters squared. Okay, and finally I want to show you if they ask for it in terms of pi. Okay, so again, I'm going to take down the formula exactly in full, and I can't fill anything in for the A, but the pi this time, if it's in terms of pi, I'm just going to leave it as pi, right? And or is still going to be 12, so sub it in, close the bracket, don't forget the squared, and this time I'm going to get my calculator and I'm going to type it in like that. So I'm going to put the pi button in on the calculator. Can you see that down there? I'm going to have to press shift and then this button down here in order to access it, and the pi symbol comes up. So pi bracket 12, close the bracket, squared, just as I have it written, and press equals, and there we go, 144 pi is my answer. And that is the answer then in terms of pi, because in terms of pi means you've got to have pi in the answer. So centimeters squared, and it is close to what I have already. If I press the S to D button, you'll see that it is equivalent to 452 point, and again slightly different on the decimal places because it's another approximation. Pi is the closest one. All right, that's going to give you the most accuracy. So I would advise that if you are not given a particular specific approximation for pi, if they don't ask you specifically to use 3.14 or 22 over 7, I would use the pi button on the calculator and change it to decimal form if the question asks you for the answer in decimal form. But if it asks for it in terms of pi, leave it there like that with the pi in the answer, 144 pi centimeters squared. Okay, right, that's area in a nutshell of a circle and all the different ways you might be asked to use pi. Now we're going to stick with this example here, and what I'm going to do now is I'm going to use the other formula that is here in your log tables on page 8. Okay, so as I said, A is obviously the area formula, L is the length of the outline or the outside. So in other words, it's the circumference. Okay, so let's find the circumference or the length of that outline of that particular circle. So the first thing I'm going to do is I'm going to take down the formula. L equals 2 pi r. Or if you want to use C for circumference instead, that's something that we use quite often, so it's up to you. Okay, I'm going to follow it exactly as the way it is in the log tables, all right? So this time, let's fill it in. Obviously, I don't know what that length is just yet. 2, keep as 2, obviously. Pi, let's put in 3.14. All right, again, you just check exactly what it's asking you to take pi as in the question. And or, well, that's just the radius, which I have, which is 12. So again, sub it in with brackets. And now we'll get our calculators and we will do 2 bracket 3.14, close the bracket, open the bracket again, 12, close the bracket, and you have it typed exactly as you have it here. Press equals. Again, you've got a fraction, so I'm going to press the S to D button, and I have 75.36. So the length of the circumference is 75.36. Now, because it's just a length, it's just going to be centimeters, okay? The only time it's going to be squared is if it's area, and this is not. This is just a length of the outline. So the answer is 75.36. Okay, and that's how we use that formula. Very straightforward. Follow it exactly. Okay, now let's come down here to this next example, all right? And this time what I'm going to do is we're going to find the area and the circumference of this circle here. Okay, this time let's take pi as 22/7, all right? Okay, so let's do the area first. And the first thing I'm going to do, obviously, once you go to your log tables, you're going to take that formula down exactly and in full. So we have a equals pi r squared. So we're looking for the area, so obviously I can't fill in anything for the a. And then pi, I'm going to sub in as 22/7. The radius, now, this time if you have a look at that circle, I don't have the radius. I have the length of the whole width, the line going from one end of the circumference through the center to the other end, and that is called the diameter. Okay, so the diameter is 8 centimeters in this question. All right, now I don't use the diameter in my formula. I need the radius. But of course, the relationship between the diameter and the radius is that the radius is half the diameter. So if you're given the diameter, be very careful to watch out for this, because sometimes they can sneakily put in the diameter and pupils mistake it for the radius. You need to make sure you have the radius for the formula, but you may be given the diameter. So what I'm going to do is I'm going to divide by 2. 8 divided by 2 is 4. So 4 is the radius if 8 is the diameter. And now I have the information for my formula. Don't forget to square it. And now I will do that on the calculator. So I have bracket, put up your fraction, 22 on the top, 7 on the bottom, close the bracket, open the bracket again, 4, close the bracket, squared, equals, and change it to the decimals, 50.2857. I'm going to do this to 2 decimal places, guys. So if you look here, 50.28, it's always the number after that is going to be significant. Given that that's a 5, that is going to bump up the 8. So that's going to become 50.29. And that is the area of that circle, 50.29. Don't forget its area, so don't forget your units squared. Now we're going to get the circumference. And again, I have L equals 2 pi r, taking it down exactly from the log tables. That is your formula for circumference. So I don't know what the L is. That's what I'm looking for. 2 says 2. Pi, we're using, of course, 22/7. So put it in brackets. And the radius, well, the radius, of course, I figured that out already for my area. The radius is 4. So make sure you're subbing in 4, the radius, and not the diameter. Okay, so be very mindful of that. And now I'm going to sub that all in onto the calculator. So I've got 2, bracket, and then put up your fraction, 22 on the top, 7 on the bottom, close the brackets, open the bracket again, 4, close the brackets, equals, and in decimals I have, again we'll do 2 decimal places. Read the question carefully to see, do they want to do decimal places, or what form do they actually want the answer in? I'm going to do 2 decimal places here. I've got 25.14. Look at the number after always, 2. 2 does not bump up the 4, so we leave it as 25.14. And of course, the units are just centimeters. Okay, now we're going to take a look at when we are given results like the area or the circumference, but we have to work backwards to find the missing lengths. Okay, so here's a typical question. Say I give you the area of this circle and I tell you that it's 324 pi centimeters squared, and I'm asking you to find the radius length. So immediately what you're going to do, the minute you identify the shape, the minute you realize it's to do with area, that is get your formula written out in full. So we know that the formula for area is A equals pi r squared. All right? Always what you do when you identify the shape and identify what we're talking about. In this case, we're talking about area in the question. So area of the circle is the formula you need. Now, let's fill in what bits we know. So A is obviously 3, 2, 4 pi. Okay, so put that in for the A equals. Now it's quite clear that the answer is given in terms of pi. So that tells us to keep pi as pi. All right? The radius, of course, is the bit we don't know. So you're going to have to keep that as r, but don't forget that it is, of course, squared. Now this looks quite complicated, okay? You're going to get a lot of marks, by the way, just by writing down that line. But what I do next, what I need to do, and again, think about your solving equations here. You want to get r on its own equals. That's what you want. So I want to get rid of the pi and I want to get rid of the squared to be able to strip that back to get the r on its own. So what I'm going to do first is I'm going to get rid of the pi. Now the pi is attached to the r squared. So remember what that means with algebra. When you have things beside each other like that, it always implies that it's being multiplied. So if that pi is being multiplied to r squared, how will you get rid of it? Well, you'll do the opposite. So instead of multiply by pi, we're going to divide by pi, okay? If it's multiply here, we'll divide to get rid of it. If I divide the right-hand side by pi, I'm going to need to divide the left-hand side by pi. So that gets rid of that, and it leaves me with r squared, of course, and then 324 pi divided by pi, well, that cancels with that. But if you're unsure about that element of it, even if you do that on the calculator, 324 pi over pi, you see the pi's just cancel and give you the 324. So there we go, 324 equals r squared. You see the r squared is still left. I want the r on its own though. So now, how do you go from squared, or how do you undo a square, if you like? To go from r squared to r, we must undo the square by square rooting it. So r is going to be equal to the square root of 324. So that's what I'm going to do next, square root of 324, and the answer is, of course, 18. So 18 units is going to be centimeters. It's just a length. 18 centimeters is the radius of the circle. Okay, now let's try this question where again we're asked to find the radius, but we're given the circumference of the circle, 56.52 centimeters. So as always, when you identify the shape, when you identify what it is that we're looking at in the question, which is circumference, get the formula written out in full. And the formula for circumference is L equals 2 pi r. So this time, of course, we have the circumference length, which is what the L is. So instead of L, I'm subbing in 56.52 equals. On the right-hand side, the 2 stays as 2, and the pi, of course, I'm told to take it as 3.14. So sub in 3.14 in brackets for pi. And the radius, of course, I don't know, so we may leave it as r. Now, again, remembering how to tackle your solving equations, if you want to get r on its own equals, we need to get rid of the 2 and the bracket 3.14. Now, of course, brackets means times, and what you have here all together attached to the r is something that's being multiplied to the r, okay? So in order to get rid of 2 bracket 3.14, I'm going to divide by 2 bracket 3.14, okay? To get rid of something that's being multiplied, you must divide by it, okay? If I divide by it on the right-hand side, that means I've got to do the very same thing on the left hand side, divide by 2 bracket 3.14. That gets rid of all of that and leaves me with the r then all on its own. And on the left hand side, I'll do this on the calculator. So I have 56.52 on the top, come down to the bottom, 2 bracket 3.14, type it in exactly as you see it and the way you have it here, equals, and the answer is 9. So 9 centimeters is the radius length. Okay, so before I move on to sectors, I want to just go through two examples of questions that can come up with circles, tying in with some work we did before on area of squares, rectangles, parallelograms and triangles. And the idea being when you have irregular shapes or in between areas. Okay, so here's an example of an irregular shape. All right. So what we got to do with these irregular shapes, if we've got to split them up into shapes that we do know how to get the area of. So what I'm going to do here is I'm going to split it up into this shape on top, we'll call it A, and this shape on top, we'll call it B. Okay, so because I've got this line here, it's split up quite nicely already, and the shape on top is a semicircle. All right, so what I know to do here, to get a semicircle, I'll need to get a full circle and just half it. Okay, so for shape A, I need to consider the area of a circle. So straight away I'm going to write down the full formula, A equals pi r squared. All right, and what I'm going to do at the end, I'm going to half it. All right, because I've got half of a circle sitting on top. Okay, so now I need to consider what information I need for this. So first of all, it doesn't tell me what to take pi as, all right? So I'm going to use the pi button on my calculator because that gives more accuracy. So I'll write, obviously I don't know what the area is just yet, so keep that as A. Pi, I'm going to leave as pi. I'm going to put it as pi on the calculator, right? Use the pi button. Now, the radius. Okay, look at your diagram. Now, it's not clearly given to me what the radius is, but I must have enough information to figure it out. So remember what I said the radius was, anything from the center to the circumference of the circle. So I want that length there. So what's going to help me here is the fact that the full length across is 16, which must mean that halfway across is 8. So the radius, so be very careful of this, look carefully for the information to get the correct dimensions. The radius of that semicircle is 8. So put it in as 8, close the brackets, squared divide by 2. Okay, so doing that on our calculators, we're going to put in pi, okay, bracket 8, bracket squared, equals, and then divide it by 2, and change the button. We'll put it in decimal places. 2 decimal places will give it to 100.53. The 0 obviously doesn't make the 3 bump up. So 100.53 centimeters squared is the area of the top semicircle. So now we'll go on to shape B, and shape B quite clearly is a rectangle. So the formula for the area of a rectangle is A equals L times W. All right, get it written out in full. So obviously we don't know what the area is, but the length we can see quite clearly is 16. And the width, now we don't quite have the width either. We have the full length, okay? So how are we going to figure out what just this width is? Just the width of the rectangle. Well, given that we know the radius length is 8, that means that any radius length, oops, went a bit too further, up to the circumference, they are all 8 centimeters. So including the one that goes directly up like this, which means that width there is also the same as that radius length there, which means it is also 8. So if that length is 8 and the full length is 20, that means that width must be 12. So the width of the rectangle is 12. So 16 times 12 is 192 centimeters squared. And so my total is going to be 292.53 centimeters squared. Okay, so let's try this in between area now, And as I said, remembering from the last video how to do in between area, you always do the larger shape, which quite clearly is the rectangle. So we'll be doing the rectangle. Subtract the smaller shapes, two smaller shapes in this case. So we have a circle and then we have a smaller circle. So if I have the larger rectangle and I take out the two circles, I'll be left with the area of this shaded region here. And that's always how I tackle any in-between area. So the area of a rectangle is, of course, length times width. The area of a circle is, of course, pi r squared, and the area of this circle is, of course, pi r squared. So the length times the width here, well, the length is 20 and the width is 16. That gives me a total area of 320 centimeters squared. Then we have pi r squared, so we'll leave pi as pi. We'll get better accuracy, given it hasn't been specific in the question what to take pi as. The radius of this larger circle, quite clearly the radius is 4, so put it in brackets and square. So I get a equals, and I'll do this on the calculator, pi bracket 4 squared equals, and we'll give it to 2 decimal places. So I have 50.2. The 6, of course, will be bumped up because the 5 comes after. So it would bump up to 27 centimeters squared. And the smaller circle, of course, will be pi bracket 2 is the radius of the smaller circle squared. So that gives me, again, I'll do it on the calculator, pi bracket 2 squared equals, and I'll give it 2 decimal places, 12.56. The number after is also 6. That second 6 will bump that first 6 up to 7, so centimeters squared. So now I'm going to do 320 subtract 50.27 subtract 12.57. So that gives me 320 minus 50.27 minus 12.57 equals 257.16 centimeters squared. And that's how I tackle those in between areas.